Hi everyone, welcome to a video series I like to call the A to Z of Python. The premise is that we'll cover a different topic in each video from A to Z, and we'll pick out an idea that matches each letter and we'll go for it. So because today is the first video, I'm going to start with the array, which is a powerful concept in both mathematics and computer science. It allows you to manipulate large sets of data, do all kinds of great things, and right off the bat, even if you're brand new to Python, you're going to be using some sort of data structure. You just have to. It's the only way to really keep large sets of information without creating a bunch of variables. And probably, even if you've never programmed before, day one, day two, something like that, you're going to cover some basics of certain types of arrays. And in Python, there's several different containers that we can use, and they all perform slightly different functions. So let's go over those, and by the end of this, hopefully you'll be well versed enough to know where to start, or maybe you'll learn something new. So the first one we want to talk about is what's called a list. Now in Python, a list is, I think, sort of the foundation of everything. It's a container of objects that can really hold just about any type of data that you want to store in there. And that's interesting. It can hold integers, strings, other lists, other data types, all kinds of stuff. And it's powerful in the sense that it's easy to iterate over or to sort of index through. And I'll show you how that works here, and that'll make more sense if you're not quite sure what I'm talking about. So let's create our first list, and we'll just make it a small one, and we'll fill it with some numbers. And let's print this out, and we'll see how Python handles this. So if we execute our code, the console shows the simple list 1, 2, 3, and that's pretty much what you would expect. Now let's say we want to reference a particular spot in this list. So let's say we want to get to number 2. Well, these are indexed from 0, meaning the first number in your list has a placeholder of 0 or an index of 0, and this would be 1 and 2 and so on and so forth. So if you kind of got to mentally subtract 1 from whatever place you want to get. So if we want to get the second number in our list, that's index 1. So it's index 0, index 1. So we'll put A index 1, and we can print this out, and we are return the number 2, which is the second object in our container here. So in order to navigate through lists or point specifically to an item in a list, you just put the list index inside these brackets, and you can get whatever number you want. So we put in 2, we should return a 3. Okay, we change this to a different number. We print out 0 index. We get 55. So again, it's got nothing to do with the content. It all is based on its order in the list here. Now, referencing individual items in a list is pretty cool, but sometimes you may want to do something with the entire list. And in some programming languages, specifically older ones, it's kind of cumbersome to navigate over lists. You have to create some sort of counter. Maybe you need to know the size of the list. Well, all that's handled for you in Python. You don't need to know really what the size of your list is in order to perform some sort of operation on it. So we can use a for loop. We can say for item in A. Alright, so this item is going to represent each individual object in our list. And so say for each item in A, let's print it out. Print item. Okay, so this is going to print the item at each index of A. And if we run this, we see it does just that, 5523. Okay, so that's pretty cool. So we can do some different things. We can modify the item, say times 2, and we get each item times 2. And we can do all kinds of stuff in here. But what's interesting is if we now go past this and we print A again, we're not returning the values that we printed, we're returning the original values of the list. Now that's quite logical if you understand that the print isn't really modifying the information, it's just temporarily making some changes in order to write it to the console. So that begs the question, how do we actually manipulate data inside the list? Well, there's a couple of ways. We can do all kinds of things. So we could say A0 equals 1 to kind of reset our list. We'll print A. Alright, so we've assigned this list and then we've modified index 0 to be 1 and we printed that out. So you can directly address the objects within your container by using their index and then assigning that to a variable. That's one way. We could do a for loop just like we did before. We can even do things like a.append, which is a method, and if we look in, if you're using an IDE such as PyCharm or something like that, a lot of times you'll get a list of the methods you can do here, such as count, index, pop, reverse. There's all kinds of really helpful ones here, sort, all kinds of things. But if we do the append and we put in, say, 4, let's change this to a 1. So we'd expect it to be 1, 2, 3, and then it adds a 4. So let's print that out, and there you go. So these lists are quite powerful, they're very robust, they're easy to use, and there's a lot of built-in methods to modify your list. Now a list, like I said before, can contain all kinds of information. So this is a list of integers, but what if we put a string in there? Alright, and we print that out. No problem. So it can contain all kinds of stuff. It could even contain a list of other lists. I mean, it can be whatever you want. And it's essentially iterated over in a similar way, pretty much despite whatever's in there. It doesn't really matter. So lists are very basic, but very powerful. And I would say for most of your array needs, the list will suffice quite well. But there are others. There's one called a tuple. Now this is a data structure that is almost in every way like a list with the few exceptions. So let's make B equal to, now instead of using the brackets we're going to use parentheses. We'll do 1, 2, 3. And let's print B. Perfect. So it functions the same way as printing a list, except you'll see that it carries the parentheses over with it instead of the brackets. So we know that it's a tuple, not a list. And we can address it the same way. So if we do B index 0, we get 1. Okay, so that works the same. If we do for item in B, we have the ability to print item. Okay, so iterating over a tuple is the same as iterating over a list. But there are some things that we can't do. For example, we can't do b.append. That doesn't exist. You notice we get an error with our IDE, and it also does not auto-populate. If we tried to force it, we would say the error message that the tuple, you can't append to that. It's not an attribute of that object. And that's because tuples are what is called an immutable object. That means that you cannot change the values after they are assigned. You'd have to actually reassign B to something totally different, so B equals something different, in order to do that, and you'd have to redefine each one of these values inside your tuple. Well, that sounds kind of painful to not be able to modify. You know, we can't do B index 0 equals 4. Doesn't work either. Alright, so you can't assign values. You just can't do that. Think of it as sort of a constant. It's permanent. So why would you use this? Well, if you're going to use this tuple throughout your application, let's say it's a key, like a key value of some sort that never changes, and you use it repeatedly throughout your program, Well, A, you wouldn't want it to be accidentally modified with your code, because then your key would change and it would throw off your results. And in addition to that, you get a little bit better performance out of a tuple because it's fixed. Python knows what it contains and the size and everything else, and it's not going to change. And there's a little less overhead. So you don't have to use this type. In fact, using a list where you probably should have used a tuple will almost always work just fine. Okay, this is just another option, and it has some uses that are a little more practical as we go on, specifically when we talk about dictionaries, which is actually the next thing that we're going to cover. A dictionary is a pretty powerful type. It doesn't just hold information, but each piece of information has what's called a key. And the best way to demonstrate that is just to create one and let you see what I'm talking about. So dictionaries are constructed with the curly braces as opposed to the brackets or the parentheses. And inside each dictionary you'll have what's called a set of key value pairs, and a key is like a descriptive term. So we could say age, let's say it's a 3-year-old, and have weight. No idea how much a 3-year-old would weigh, but let's just say it's 30 pounds. And you have height, and let's say they're 35 inches tall. Alright, don't forget your commas in there. So we've officially constructed a dictionary, and let's print that out. Alright, so it's a good basic practice when you're learning new data types to create one and print it and see how Python handles that. So let's give that a shot. There you go. So it prints just like everything else. It just gives you the object itself. What we see here is that we have a key and a value separated by commas. So there's a comma separated key value pairs. And we can try to get a particular component of this by the index. Let's, if we thought that this was the first item, so it would be index 0, we could apply the same logic that we do for lists and tuples. But if we run this, it doesn't work, and you get this error called a key error. And what's telling you is that you do not address dictionaries by index, you address them by keys. So instead of using index 0, we'll just use the key name. So let's try age. Okay, so this looks a lot like the list and the tuples, but instead of using a numerical index, we use the key, which is a string here. And we get 3. So the age for C is 3. Pretty straightforward, and when you're just doing it individually like this, it's pretty hard to mess up. I mean, it couldn't be much easier than that. So we can change this key to whatever we want, and when we run it, we'll get the corresponding value to that key value pair. Much like lists and tuples, we can iterate over this, and there's a couple of ways to do it. We could say for key in C, print key. We'll run that. Okay, so that's going to say for each key in this dictionary, print the key. But what if we want to print the key and the value? Well, how would we do that? Or what if we wanted to print, let's try to print the value itself. So we would actually refer to the dictionary and then put key in there. So what this is going to do is it's going to print the dictionary, but it's only going to print the key itself. And because this is iterating over every single one, it'll sub in age, it'll sub in weight, and it'll sub in height each time it runs through the loop here. So if we were to run this, we can get the values instead of the keys. So we can either run the key itself, print the key itself, or we can print the index, key index, right? So we can just say the dictionary name, sub in the key here, and we'll get the value. So that means if we want to get to where this looks, like the dictionary structure itself, we could say key, comma, colon, comma, and then put the actual value in there. So this will print, hopefully, the key, a colon and then the value that's at that key. So let's see what we do here. Perfect. Okay, so that's pretty cool. So we're able to print the dictionary as it looks in Python in our actual code. And this is handy if you have a dictionary you want to print. Like say, for example, you have a bunch of dictionaries that are different students and you want to get the stats on a particular student or patients at a doctor's office or something like that. This is a way to print the detailed stats of each entry in your dictionary. Now there's another method. This is kind of a Python thing to do here. It's to do for key value in C, and Python's smart enough to realize that C is a dictionary and that there's a key and a value in the dictionary. And we can, with any luck, modify this to print that. Now you would run this and expect it to print the key value. Let's see what happens. Alright, so you get this kind of cryptic error here. And the reason that is that if we're going to use this method, we have to do what's called items. And that is going to tell it to find the key value pair for each, what they would call an item, which would be each key pair value in the dictionary. And that's not really an intuitive thing right off the bat, but you just have to know that this needs to be added if you're going to do it in this method. But I like this method because it looks better and it is a little more straightforward visually. If you're reading what this is doing, it makes a little more sense. So we run it that way, we get the response that we're looking for. This .items function is actually, I believe, unique to Python 3, and it is, I think, iteritems in Python 2.7. I could be wrong, but if you're running an older version of Python, .items does not work. You'll want to look in the documentation to figure out what that is. But I think it's .iteritems. So you can give that a shot. If that doesn't work, just look it up. So now we can see how we can iterate over all the different types. So let's talk about some limitations to these, and then we'll expand on that. So first of all, what might you want to do with a list? Well, one of the things I would think of is to do some sort of mathematical functions to that. So in just the most basic example would be to multiply the list contents by some kind of integer. So for example, if we want to say D equals A times 2, in my mind, naturally, I would think that D would then equal 2, 4, and 6. I mean, it only makes sense, right? You're multiplying you're multiplying A by 2. So let's see what happens. Let's print out D. And we get kind of an unexpected behavior here. It doesn't multiply the individual values. It, in fact, just sort of doubles the contents of the list. So it assigns it to the list twice, which, if you are using this for any mathematical purposes, is probably contrary to what your goals are. You're really hoping, I would expect, to be able to manipulate all of the data inside the list at one time, and it in fact does not work that way with Python at all. So there are some ways to do this. Let's say we keep D as a list, and we'll have it as an empty list, and we'll say for item in A. So we're going to iterate over the A list again, and we'll say D dot append. So we're going to add some kind of result onto D, and we'll put item times 2, and then we'll print D. So this time, when we run it, we get the behavior that we're looking for. So it's not to say that you can't do mathematical functions on lists. It just is to say that if you're going to do, if you want to modify the actual entries in a list mathematically, you have to loop over the entire list and do it one item at a time. And for small lists or infrequent uses, this is quite simple. It has a benefit of utilizing the default options in Python without having to import any different modules, which is nice. So it's just pure Python code here right out of the box. And it's simple, and you'll be using a lot of for loops anyway. So this isn't a bad approach. However, for very, very large indexes and multi-dimensionals, like nested ones, and for linear functions and things like that, you would probably prefer to just manipulate the entire array in one function, and that's like a linear algebra type thing. And that's where I say that if you're from a math background, you're using stat software like MATLAB or R or something like that, you're probably used to being able to directly manipulate the entire list with one function, such as a times 2, and you would get 2, 4, 6. Well, it doesn't work that way in Python, sorry. There are solutions around that, and we're going to cover that, but for that's a little bit more advanced than the basics, but that's something that you're going to probably eventually want to do, so we'll cover it. So what else can we do before we expand to that? Well, you can dig a little deeper, and you see that there is something called an array in Python. So these are technically types of arrays, but it's not an array. It's a list. It's got a different name. So there is something called an array in Python. So maybe that will give us the result that we're looking for. So let's type in from array import star. Okay. So let's give that a shot. And well, maybe not. No, that should be okay. Apparently not. Nope, if I can type. There we go. You got to spell it right. That's important. That helps a lot. Okay, so not from array import star. So now we've imported the array data structure, and we can give it a shot. So let's try to create an array, and what we'll do here is create a new one, and we'll use a pretty interesting function. So let's do b equals array, and arrays are interesting in a sense that you have to tell it what type of data that your array is going to hold, and it doesn't like a list can hold anything, any type of objects that you want. An array cannot do that. It can only hold one data type. So we're going to use just a good old integer, and that is something that if you look under the array documentation in Python, you'll see that there are quite a few type codes that you can use to specify to Python what type of data that your array is going to store. So these cannot hold an integer and a string. It can only hold all of one type, but it can hold just about any type. And these are your options. Okay, so numerical options, and we're using the lowercase I, which is a signed integer, which means it can be positive or negative, and that's pretty cool. So let's say we created this array. It's empty array, and we can do something called from list. So b.from list, and we tell it the list, so we'll do A. So what we're doing here is we're saying create this array B, and then take a list, which is A, and convert that into an actual Python array. So if we were to then print B, and B's may not be the best letter here. Let's change this to E since we've used B earlier. There we go. So we've created the array, we've taken a list, and we've converted that into an array, and we'll print that out. And let's get rid of this print statement just to clean it up. And there you go. So this prints out just like everything else. It shows you what type of data structure you have. This is in fact an array of signed integers, and the contents of which is 1, 2, 3. Well, let's try. Let's try to print E times 2 and see what happens. Well, unfortunately, same exact thing happens as it does with the list. It just duplicates the array. So arrays are not the solution that you're looking for if you're trying to do this from a mathematical perspective, but arrays are, again, more efficient than lists. They are mutable, meaning they can be modified. They can be addressed by index and reassigned, just like you could with a list. If you want to change the contents of the array, you certainly can. And because it's only using one particular type of data, you cannot input the wrong data, and you can't overload your system as much as you would, say, with the list. So, every time you're able to limit what something can hold, you will lower the overhead. So you may probably never use an array, but if you're always using the same data type and you want to use this array capability in Python, you could, but not very common, but it does exist. And since we're talking about arrays today, why not bring it up? So there you go. And let's see some other things. Before we get into the math side of it, let me show you something kind of neat that you can do with Python that's pretty powerful. So what we're going to do is let's get rid of all this. And let's remove this import statement. And we'll use some nesting here. What we're going to do is we're going to use tuples as a key to a dictionary. And those of you using this for math purposes will enjoy this particular segment. So let's try some kind of equation that's got x, y, and z as variables. And we'll set x equal to something, say 3. And we'll set y equal to some other number, 6. And then we'll set z equal to some kind of equation, some kind of more complicated equation. So let's just try negative x plus 2, and maybe we'll multiply that by something else. Let's try, I don't know, y plus 7, and let's divide that by 3. Okay, so this is some sort of basic math function here. So x and y are defined with an actual integer, and z is defined as a function of x and y. So as the x and y change, so will the z. But we don't know what z is as of yet. We can print z, and we see that it's executed the math. It's, put in a -3 here, and it's put in a 6 here, and it's done the math, and it's given us -4.3. So that's great. And what else can we do? Well, let's use some loops here. And I'll do for x in range 1 to 11, and for y in range 1 to 11. And don't forget your colon. So what does this do? Well, if you're trying to construct like a two-dimensional array, I guess you could say, like a matrix, or imagine this as a chessboard or a game board or something like that, or on a plot system, points from 1, 1 up to 10, 10. And the reason it's to 10, 10 is that's just the way the range works. It's the upper limit here, 11. It will actually only go to 10. So this will be one more than what your range you want to be. So what this is going to do is it's going to run through some loops, and it's going to say for x equals 1 and for y equals 1, do something. And then it will say for x equals 1 and y equals 2, do something. And it will run through that all the way to x equals 1, y equals 10. And then it'll have completed all of these, and it will go then to x equals 2, and it'll go 2, 1, 2, 2, 2, 3, so on, and then 3, 1, 3, 2, so on and so forth, until it ends up at 10, 10. So we're going to get the entire range of x and y up to 10. And let's just kind of steal our formula here and paste that in. And let's create a dictionary called solutions. All right, it's an empty dictionary. And let's assign the key value as the x and y values in a tuple and the z value as the dictionary value of z. So that's going to look like this. Solutions, and our key will be a tuple of x and y. Hopefully you follow what's going on here. And that's going to be equal to z. So what we would expect is solutions to fill up with values as this loop runs. And the x and y, we should have every value of x and y from 1, 1 to 10, 10. And the corresponding z value based on this formula here. So let's try that, and then we'll just print the solutions here. And there you go. And that's kind of nasty looking, so maybe we'll use for key value in solutions. So this is just like from before, that items. And we can get rid of this. And we'll print key. And instead of putting the colon here, we'll just use equals because we're doing some math here, and that looks good. And we'll put value. And let's see what happens here. Don't forget your comma. There you go. So your ID is pretty good at telling you when you've messed something up. So that's why it's always helpful. And there you go. So that's kind of the output that we're looking for. Same output as before, it's just there's a line break here after each one. And so this is pretty helpful. So this will show us for any xy value what the z value is. And again, this is just another usage example of where tuples are pretty cool. They're never going to change, right? Because we have a list of them, like a whole range. And they work really, really well as a key. And to show, kind of extrapolate on that a little bit, we can say print, and we'll do solutions, and we'll try it for, say, 3, 5. So what we're hoping here is to say, actually, let's go on this. So we can put in some context here for the values x equals 3 and y equals 5. The z value is, and put in solutions 3, 5. So this is going to reference the tuple 3, 5 and give us the z value, and there you go. So pretty cool. And that's pretty powerful, I think. So that's just another example of how these different types can kind of interact with one another, and you can build them inside of each other to add some power to your programming code, very simply. So last but not least, there is something that will allow you to do functions, or excuse me, arrays in the traditional sense, and that is called NumPy. And NumPy is a free module. You can install it through pip on Linux, or you can download it and install it manually with pip on Windows. And once you have NumPy installed, you can create what's called a NumPy array. And the way you do that, you initiate this, you import your module. So we'll do import NumPy as py. That's sort of the standard procedure. And that allows you to call all kinds of cool stuff. So you see here, we can take NumPy array. Nope, not as py, as np, sorry. There we go. Now it's lining up. So now we can create an array. And let's say a equals that. And let's print a. Again, we're just printing these each time so you can see what they look like and the way the system thinks of it. There you go. So it looks just like a list. It prints identically to a list, but does it behave like a list? Well, let's print a times 2, and we'll give that a shot. So with list, you would just end up getting 1, 2, 3, 1, 2, 3, like we saw that before. If we print a NumPy array, well, there you go. We get 2, 4, 6. And that is the magic of Python. If you're looking for a particular function or particular behavior, there's probably someone who's done it before, and you can just import the module that gives you the capabilities that you're looking for. And the NumPy arrays behave the way you would expect a mathematical array to behave, and therefore if you're using it for, say, machine learning or vector geometry, linear algebra, something like that, you're going to want to use the NumPy array, because we can take huge sets of numbers, and you can, if you're doing multiplying the different arrays together, and like in a linear algebra style, you can use one step to do complex calculations, as opposed to having these for loops that are potentially thousands of instructions to do something that could be done in one line of code. And so for those of you who are interested from a more mathematical approach, I would highly suggest digging into the NumPy documentation, following through some examples, and using this type of array. So that about wraps it up for the very first video of the A to Z. And I hope you learned something today, and tune back in for the next one, and I hope you have a great day. Thank you.